All right, tonight we're diving into one of the most studied galaxies in the sky, a real cosmic powerhouse known as Messier 77. And it turns out this galaxy has been hiding some pretty electrifying secrets.
So, when you look at M77, which also goes by NGC 168 or Cetus A, it just seems like this gorgeous, classic spiral galaxy, right? It's a standout in the constellation Cetus, the sea monster. But get this, it's a staggering 47 million light years away. That means the light hitting our telescopes tonight started its journey when giant prehistoric mammals were still roaming the Earth. Just think about that for a second. For a long, long time, we thought it was just a pretty face in the cosmic crowd. But astronomers had this nagging suspicion that something incredibly energetic was happening deep in its core, something totally hidden from our view. So what exactly was going on behind the curtain? To solve this mystery, first we've got to talk about how astronomers classify active galaxies. It's a key step that led them to a really brilliant trick for, well, seeing the invisible. You see, active galaxies, also called Seyfert galaxies, basically come in two main flavors. With the type 1, you can look right down into that brilliant, blazing core, where a supermassive black hole is just feasting. But with the type 2, like M77, that whole show is hidden by this thick, donut-shaped cloud of dust and gas. We knew something powerful was in there, we just couldn't see it directly. So the key to peeking behind this dusty curtain? It all comes down to a property of light called polarization. Imagine light waves are vibrating every which way. Polarization is like running that light through a comb, forcing all the waves to line up and vibrate in just one direction. And that combed light, it carries fingerprints of the last thing it bounced off of. And way back in 1985, two astronomers, Robert Antonucci and Donald Miller, used this exact trick. They measured the polarized light from M77 and made an absolute landmark discovery. They found, in their words, a definite set of proofs that a super powerful Type 1 engine was hiding inside this galaxy we all thought was a Type 2. Here's how it worked. The direct light from the core was totally blocked. Yeah, but a tiny little bit of it was escaping. It was shooting out, bouncing off gas clouds above and below that dusty donut, and reflecting right back at us. That reflected light was polarized, and when they looked at its signature, it was a dead ringer for a Type 1 galaxy. They had basically found the ghost of the hidden engine. Incredible. But the story doesn't stop there. Not even close. Decades later, a completely different kind of discovery added this whole new layer of mystery, shifting our focus from hidden light to, you guessed it, ghost particles. So fast forward to 2022, the IceCube Neutrino Observatory, this gigantic detector buried a mile deep in the Antarctic ice, spots something unbelievable, a whole stream of high-energy neutrinos, and they are coming straight from Messier 77. This was an absolute game changer. Now, this was a huge deal because neutrinos are ghost particles. They almost never interact with anything, so seeing high-energy ones is what scientists call a smoking gun. It's definitive proof that cosmic rays, which are actually super fast protons, are being accelerated and slammed into things. It's hard evidence of a colossal natural particle accelerator at work. And that, of course, immediately raises the next massive question. A hidden engine is one thing, but what in the world inside Messier 77 is powerful enough to rev up particles to nearly the speed of light and create these neutrinos? The answer, it turns out, lies in the chaotic, superheated chaos right at the edge of the galaxy's supermassive black hole. It's a place powered by one of the most fundamental forces in nature. The prime suspect here is something called the AGN corona. Now, this isn't a crown of light like on our sun. It's a turbulent, insanely hot region of magnetized plasma just whipping around the black hole. And the key word, the most important word there, is magnetized. So the leading theory basically goes like this. First, you have these incredibly strong, tangled magnetic fields churning violently in the corona. They act like a cosmic slingshot, trapping protons from the plasma and accelerating them to unbelievable speeds. Then, these supercharged protons smash into nearby gas and light. And in that collision, bam, high-energy neutrinos are born. And those neutrinos, they just fly straight out of the galaxy, totally unimpeded, until they hit our detector millions of years later. Okay, so we have magnetic fields powering a particle accelerator. But that just kicks the can down the road, right? It begs another, even more fundamental question. Where do these powerful cosmic magnetic fields even come from? This all boils down to some fundamental physics. Out there in the cosmos, you're not going to find giant bar magnets just floating around. It doesn't work like that. The only way you can generate the enormous magnetic fields we see in galaxies is with one thing: massive, flowing electric currents. Magnetism is just one side of the coin. The other side is electricity.
If you want a relatable example, just look at our own sun. We have models that show these huge electric currents flowing inside and around the sun, and that's what creates its powerful, tangled magnetic fields. The engine at the heart of M77 is the exact same principle, just scaled up to a degree that is almost impossible to imagine.
And this is why M77 is so incredibly important today. It's not just some galaxy with a hidden core anymore. It's a perfect, nearby laboratory. It lets us study the raw physics of the universe's most powerful electromagnetic engines, places where matter, energy, electricity, and magnetism are all pushed to their absolute limits.
But actually studying these forces is unbelievably hard. I mean, direct measurements of the magnetic field in just one tiny part of M77's core could only give us an upper limit, less than 2.5 Gauss. Now, that's only about 5 times stronger than your average fridge magnet. But when a field like that is stretched over immense cosmic distances, it's more than enough to power these incredible events.
And maybe the most remarkable thing of all is that this engine seems to be incredibly stable. By digging through observations going back nearly 50 years, researchers found that the magnetic structures powering this whole thing, they likely haven't changed at all. This isn't some temporary fireworks show. It's a permanent, long-lasting feature of the galaxy.
So Messier 77, sometimes called the Squid galaxy, has shown us that by looking at the universe in different ways, through polarized light, through ghost particles, we can uncover these powerful engines driven by the invisible forces of electricity and magnetism. It just proves that some of the biggest events in the cosmos are driven by forces we can't even see. It really makes you wonder, doesn't it? What else are we missing? What other cosmic secrets are just hiding in plain sight?